Recording live from Twitch TV. We're continuing on from our game. Yesterday was kind of a wash. Couldn't quite get my mind straight on the math, but today seems a bit clearer, and so let's get started. So what we're trying to do is let's see here. Let's get this built again. Is we're trying to get the units running across our main character running around on the terrain, and so we wanted to track the cursor whenever. Looks like there's a problem with build directory, so I'm going to just clear that out, and I'm going to run our build. There we go. And so I'm going to clean this up a bit. Finally kind of came together on the math, so I'm going to cut out some of this stuff that we don't need anymore and kind of start fresh. And what we're going to do is we're going to set up a way to, let's draw the GIMP out here. So I'm going to just sort of draw it out so it's a little bit clearer to understand. This is the part I was kind of having a hard time concentrating on, was trying to find the point of reference on where things are going to fit and go into place. So let's see here, we're going to create a new So the issue is here's our guy here, and we want him to walk at a particular direction and be able to walk smooth instead of going kind of like this way, and then he kind of drags down, kind of how we were going before. So it still updates correctly here, yeah. And so we want him to. What we need to do is we need to figure out, like, let's say like let's grab another tool here, another toolbox. So if we're trying to get him to go to this point here. And so we just want a direct path between that here and here. Okay? So now what we need to do, darn, I keep doing that. What we need to do is we need to calculate where he's going to be along that line at any given point, given his speed that he can travel. So what we're going to do is, we can figure this out, is that along the X here is the way he's going to travel. That's his run, and then this is his rise. And we've got a slope here. We also have a nice right triangle here. And so we just need to calculate the hypotenuse, different spots you'll be along the hypotenuse, but we can just reuse these right triangles like so to find out where at each given point our character will be. So I'm going to shut this down. So that's the idea. So what we're going to do is we're going to define a speed that the guy will travel. So we'll just say, like, call that like the velocity. That'll be a float, and I'm just going to give it, say, 200. So that means he can travel 200 pixels in the screen every second. And for some reason, the Twitch stream isn't showing up on here, so I'm going to keep continuing on. I think it might have fixed. There we go. So we have our velocity, and we also need our hypotenuse. This will be float. So the hypotenuse is actually the distance between where we are and where we want to go. So we actually can just use our that's the wrong math util. I think I inducted the wrong one. Yeah. So we use our math util, and we can get the distance between 2 points. So point A will be our last unit, world point, and our destination, our target location, will be our ending point. So that'll be our hypotenuse. So now we just need to figure out the 2 points, but in order to do this we need another piece of information. And in this case we can actually get the angle because we have 2 points. We have the distance in points. So what we can do is we can figure out the angle from there. So what we're going to do is we're going to get the angle, that's a float, and we can use our math-util that we already created with the get direction in degrees. And so point A would be last point, world point, last unit, oops. And then we'll have our target location. And so that'll give us our angle and our hypotenuse. Now from there we can figure out our rise and our run. So now what we're going to do is we need to figure out our velocity is actually going to be so he's going to move per frame. Is this right? Actually, I want to multiply this. So 200. So he's going to move 200 times 200 pixels per second. So this is a second in our update land. This is we're doing 60 frames per second. And so we can actually make this a constant later, which we seem to be using a lot of, so we probably want to turn this into a constant eventually. And so this is going to be our change. That's our velocity. That's our change over time. So now what we need to do is we need to figure out, why is this not connecting over here? Okay, now we need to figure out, you can just make sure that we're actually recording or streaming. Yeah. Okay, so we have our angle. So now what we need to do is find the run. And so this is kind of an interesting thing too, is based on how our character's set up, we're basically calling this 0, or 0 degrees. Well, we actually want this because this is our run. So actually what I'm going to do is on our angle, I'm actually going to add 90. So that actually gives us this, our run, first. So now, let's say run equals, so the, we're going to use some geometry. So what we're going to do is, or trigonometry, is that we're going to get the length of this top side, we'll call this x, right? So in order to get that, we have our angle. So let me get a different color in here. I'll do pink. So we have our angle here, and then we have our hypotenuse. So we're trying to find x. And so what we have is we have our angle and our hypotenuse. So we have our cosine. We can use cosine on this. And if you look up here on the math, we'll see that cosine uses, where do you go? Cosine uses radians. So what we need to do is take our angle, so we're going to say math-util, and we want to get the degrees to radians and our angle. And then we're going to multiply that by our hypotenuse. And that should give us our run. Now we want our rise. So we want our rise. And so we don't want to use, do we want to use cosine? I don't think so. So we want to get our, here's our run, and here's our rise here. And so what we want is we need to find out, so we've got, we use cosine, so that's opposite hypotenuse, and then sine should be adjacent and hypotenuse, which is what we want. So we want to use the sine here. And so that'll give us our rise and our run. So what I'm going to do is I'm just going to trace these just to see that this seems sane. Okay, So let's run this real quick. Just to do a little sanity check. These numbers should seem pretty valid. There shouldn't be any big surprises. If they're not correct, then we can go back and fix our math here. So we're going to drop him in there, and then if we go along here, he is running way too fast. We're actually in the negatives, which is strange. So let's find out why that would be negative. So let's see here, trace hypotenuse, and then we're going to trace our velocity and see if we have a bit more sanity in these numbers. And okay, yeah, we are tracing our hypotenuse. And we should probably trace our angle as well. But let's drop our figure here. And so our line 74 that's our angle. Let's see, so that seems it's in the negatives. So it looks like we need to subtract 90. Because right now it's giving us 0, 0 there. It seems to be all in the negatives. So if we're 0, that doesn't seem correct at all, does it? So let's go back. So we get the directions in degrees. We got our world point, target location, and that should give us, if we want to, oops, let's clear out this here. So I want to make sure I get this correct. So get the direction in degrees. We start with our world point and our target location. I think we use this in our display. I just want to make sure I'm using this the way I thought I was. Get direction degrees, yeah. So why is that? So let's just clear this out and see what's going on. Definitely want to do a nice sanity check, make sure before we start continuing on making sure our math is correct. So here, so he's 90 degrees, he should be at 0. If we subtract 90, that should be correct. So I did have it, and subtract 90. And so we should be at 0. But I think, let's go back. Was that? No. So, yeah, there we go. That looks better. So he's actually running in the direction that we want. And it should go full circle around. Got some negatives. That should be okay. Okay, so it looks like he's spinning around as expected. So let's track our velocity. So you know the angle is working. So we definitely want to only split out this if it's, we only want to do the interval that they'll travel, that the unit will travel. So let's drop them in. Oops, wrong button. I'm going to fix that again. If last unit equals null, return, so that we don't get that ever again. All right, let's get to our velocity. Reopen. There we go. And so means he's going to travel 3 1/3 pixels every frame. Seems like a lot. Let's stick with it. I think that'll be fine, actually. So we have that. We have our velocity. Let's think our hypotenuse is correct. Let's just do this real quick, just to see. Now we've got our angle situation solved. Let's just double check the rise and the run. This happened last time. So we're going to drop them in, and the run seems a bit off, the rise seems a bit off. So we're passing the, no, that's correct, I want to use the angle. Because we should be getting the, yeah, what is the hypotenuse? So let's figure out why this is, what's this hypotenuse business doing? So hypotenuse is, should be about right, looks right. So what's the problem here? Let's do a couple more traces here. We're going to get the cosine of the run. Oh, actually, no, that's that. Let's trace this. And let's see. I think I actually have the math. No, the math is correct. Let's figure out here. So degrees 2 radians, that makes some sense. And then our 81, that's our cosine. So here are so that's right, it's actually 0, 0. So 80, line 80, okay, so 81, line 80 we have at 0 degree angle, and it's 1, so the rise is 213, which seems wrong. So actually we don't want to use our velocity. I think we want to use our, actually we want to use our velocity. Does that make sense? It should be a percentage of the total distance. So I think that's the entire distance. So if we use our velocity, we should have a piece of it. Let's drop them there. So here, yeah, that's correct. So you can see as we head directly south, actually move at his expected speed that direction. Okay, so we may not even need our hypotenuse actually. So let's ditch it, because these are basically piece by piece. It should work. Okay, so we have our rise and our run. So now what we're going to do is we're going to take the move last wizard, which we should probably name that real quick. I'm going to change that to move last unit. Huh, weird. Okay. I think my editor goes crazy, so I'm going to quit that real quick. You see my background. Hopefully that didn't kill my session here, so I'm going to make sure that, okay, it appears to still be working. Okay, so I'm going to take this move last wizard to move last unit. I wonder if it's because I don't have anything in there. Okay, so what we're going to do is we're going to take the last unit X plus our run, last unit Z plus our rise. And so now he'll run in that direction. So let me change it now. Move last unit. No, weird. Okay. So now I'm going to run this, and so he should update. He should actually run in the direction that we point him to, and it should feel natural-ish. So let's get that built out. I'm going to drop him down, and there he goes. He's really fast, so that's why I was thinking that 200 is a little bit excessive. So let's go to 100. And so we'll get a better view of his velocity. So now we're going to drop him in. There he goes. Now he's running where we want him to. But now he seems to run, that seems he is running indefinitely. He'll just run off the side of the screen, and you'll have to chase him back. And he'll just keep going. He's just bolting for it. Still seems a little fast. So I think it's because when I run this streaming software, the frame rate goes way up. I haven't quite figured out why. But when I run it without the streaming software, it doesn't appear to do that. I'm going to make sure this is recording. Appears to be. Alright, so this hopefully, yeah, it's a little bit better to watch, but there he goes. He's running around. So now we need to get him to stop. So what we need to do is we need to say if between a certain threshold of points, we need to set him to the target location. So you can say the last, so target location Z, target location X. So that'll just set him up there. So we just need to write the between. So between, and we need to pass it the actually nothing, we just need to return a boolean. So return if the last unit X is greater than or equal to, actually I'm going to do, yeah, greater than or equal to the target location of X plus our run. And our last unit dot X is less than or equal to target location dot X minus run. Actually, Actually, I want to do minus first. Plus. So if it's greater than, less than, greater than, and the last unit, z is going to be a rise, minus, and this is going to be less than z, rise. So if this is correct, I'm missing a semicolon. So now, according to this, if he runs in the positive x, negative y direction, he should stop. Nope. It's that way. So we got that way right. So let's do greater than, less than, greater than, less than. So we'll get him to stop in one direction, then we'll have him figure out how to stop in every direction. But it appears to be looking pretty good. So drop him in, and he stops, cuts out those ways, stops there. Okay, so now we got him set up there. What we need to do is we need to sometimes subtract, sometimes add. So what we're going to do is check to see if we should invert. And we'll pass it a value. And if the value is greater than 0, I'm sorry, less than 0, return true. So it means we should invert to negative, else return false. So what we're going to do is we're going to say let's see here. Actually, we could just return this. Return. There we go. Actually, we should just get the inversion. And this is going to give us a float, and we're going to return a float. So this will be better. Okay, so what we're going to do is, if the value is greater than or less than 0, we're just going to return put the value to negative itself, or yeah, return value. So actually invert it. Here we're going to try to pass our run to the float and our rise, which is also a float. Okay, so now we're passing in our value, which will be inverted or not, and we're going to inline these so that they're faster. Not function calls anymore. And now we're going to say between the invert of the rise, I'm sorry, run, and the invert of rise. So that should do it, as long as it compiles. And it looks like it's going to. And here we go. There he is. Stops, 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 stops. Now he's actually going to where we want him to go. He's stopping when we want him to. Perfect. So, what next? Well, we definitely don't want him running in place all the time. He'll get tired. So we need to have him stop and rest. And that's important when you're a hero. Time to rest. So let's do that. So I improved our tools to be a little bit more gentle. Is instead of passing the width of the frames and the height of the frames, I'm actually just going to pass it the number of frames, and it'll just do the math for us. So that's better. So how we run this is we just do Nico frame generator, and we're going to give it the number of frames wide. So 1, 2, 3, 4, 5, 6, 7, 8 frames wide, and the number of frames tall. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, and so we do 16. And then we pass it the original image dimensions, which we can see here, 610 by 1330. And we're going to give it a prefix, which is necro run, which I just happened to click the run again. And so we have our frames generated. So we need to wipe out these old ones because we don't need them anymore. And just drop these in there. Boom. I also added the standing position, and I actually added the, I thought I did, the entire Necromancer art, so you can actually pull these out as we need them. So there's our guy there, and we have our standing, which is here. So we just run the same script. This is 1, 2, 3, 4, 5, 6, 7, 8 frames wide, so it should be pretty much the same. We just need to change the dimensions. 1263, and this is Necro idle. Boom. Alright. So now we have our frames. You saved yourself a ton of time. There we have it. Okay. Shut all these down. Oops, that's too many. Okay. Now, we're going to go to our Necro display. So we have our Necro display there. We also have our game object, which is setting things up here as well. And so what we're going to need to do is abstract this out so that when we can actually tell what pose for it to go into, and also change to the different directions. So I'm going to extract a bit of this. So this thing here, we're going to reuse a lot of this. And so first of all, we need to store a different image for every pose. So we're going to say private var image poses, and that's going to be a map to a pose. We don't have any poses, so what we're going to do, we're going to create a constant here. And constants, we're actually going to create a hex poses, and that's going to be an enum. So we have idle, we have run, we have attack, we have die, and something maybe special. And we'll figure out what we're going to do with these later. But in the meantime, that'll get us a good start. So we have our poses, and we're going to store an image as our value. So here we go, we have our image poses equals our map poses image. And now we just load up our images. So image poses, set our poses run, and we're going to set our idle. Oops, idle. So we have our image data being set, and we're actually going to put this in the init so that this happens as one of the first things here. And we're going to need access to this bitmap later, so we're going to cut that And we're going to put that there so that we have it stored in the class. Oops. There we have it. And so we have our bitmap. All right. Now, this is the thing we need to have reused. We need to be able to pass a pose string to get the JSON blobs. So let's say create frames, that's what we'll call it. And we'll have a key string. No string map. So we have our string, and so we're just going to grab all this, and there we have it. Now we need to return the array of texture packer JSON array frame spec. Now we need to create a return value array, which is that. Make sure that's instantiated. So by the time we have this set, we're going to pass. No, we're going to do that yet. Instead of using directions, we can use our ret val. I'm just going to return a return value. And now we don't need an image anymore. So that doesn't make sense. And we're going to set this image data to image poses get poses idle. Make sure he starts out at idle. And directions equals create frames. We'll pass it our key, which is this guy. Key. And there we go. So according to this, I want to make sure, don't need that. I want to make sure that it's still running the same. So let's draw back. So we should have no change. Let's make sure it builds. Okay. 987. And I think that's most of it. Okay, so unknown identifier which is, so we're going to inline this so that's faster. Inline. And then we're going to async this because we're using await. And when you create frames, we have to await for this. Let's see if that gets us closer. It does. Line 77. Okay. There we go. So now, hopefully, when we do this, I think we got this little not correct still. Let's go back here. We have idle. So it's not necro JSON. It's going to be necro idle JSON. Okay. So now when we drop him on the screen, he should be in his idle position, ready to run around. We'll see. Nope, crash. Okay, so I think what do we have here? We have our bitmap, our image data. Do we have any? Actually, I think I have an idea here. So I think our renderer, if this image data is null, it'll crash, so we need to check that. Image data equal null. And we need to write a test on that, but not right this second. In fact, we can go do that. Ka2d renderer test. Where's our bitmap? There we go. So that's not it. Is there any clues? Okay, no clues. So let's find out here. Let's make sure this is succeeding. I wonder why that won't work. Oh, there we go. Now it is working. All right. Okay, so that is working. So as soon as we get to here, we need to get our image data. Necro idle. Oops. Ah, that's the problem. We don't have any necro idle. So this should get us going. There it is. So just as he was before, but now he's actually idle. But now he just skates along the ground as if he's on a bed of ice. But we have this kind of setup. So now what we need to do is, instead of having directions, we're going to have a direction pose map. And this is going to give us a map of poses. And that'll give us our array per pose. Okay? So directions pose map is going to be this. It's going to be new map poses, and that's going to give us an array of texture, packer, JSON array specs. So now this is going to be our direction pose map here. Oops. And that's going to be a set. Pose is going to be idle. Idle. And then we need to do the same thing for run. Necro run JSON. So we got our run in there. What we need to do is we need to set our direction. So this is our direction pose map. So we need to have our current. Yeah, we need to have our total directions as well. Total directions. This is going to be a variable. And now we're going to need our current frames. Private var current pose frames is going to be our texture packer JSON and frame spec. And we also want our current pose, which is that. So let's do this. Let's create a public function, set pose. Let's create a pose. And that'll set up our pose. What we're going to need to do is we need to set our image data. pose. Actually, our current pose is pose. So we're going to use that. And then so we got our image set. Now we need our current pose frames, which is this. So we're going to say equals direction pose map get current position, and then we need to set the direction, which is our current direction, so that he still faces that same direction when he changes pose. So we're going to set that up here. So our current direction is an int, and we need to make sure this is set. Current direction is an int, index. Yep. Current direction. This is going to be our current pose frames, like so. And we're almost there. We need to kill that. And we need to, so let's set direction to 0. And set our current pose to poses.idle. Current pose, so we defaulted that. We need these to be loaded first. So when our animation starts, okay, so we need our current pose frames. We just need to do the offset. We're almost there. Okay. Set direction, so he's pointing forward. That gets called twice. Set direction. Because we're going to set our pose. Oh no, we just set the direction because the pose is already defaulted. So one thing we need to do is we need to get our current pose frames, which is not set. So if we do set poses idle, that'll set these guys. Let's see here. I think I might check this. Put it here. And so we are not setting our image data, so you don't need that anymore. So if we set our pose here, it'll set that. So we set our pose to idle. Our bitmap is added. And we just need our total directions, which needs to happen before set direction. So total directions equals, we're just going to get the direction pose map, poses idle, frame, that'd be frames. 0 frames. So we're going to grab the first direction, get the frames, that gives the total directions. Alright, see if this compiles. Okay, it does not. Line 81. Okay, line 86. Alright. So now, line 59 is this returns an array. Direction pose map. Huh. So this returns, let's actually insert those. We get a ret val, which is an array of JSON texture packer direction pose map saying that 0 is not a thing. Line 59. So let's do this. Let's see if it does this. We'll do var idle. This will be an array of texture packer that. It should give us this. And see if this gives us a better. Okay, so line 59. Send that cannot be called. Cannot be called get. So I think that was what the problem was. Okay. So now, line 60, total directions. This is frames dot length. And we're getting close. Hex error. This is line 89. Direction map, get current pose frames. This is an array of those. Getting close, it looks like it's going to build. And we got it. And it crashes. Okay, so let's find out why. Let's take a look at, see if we can get, so it looks like those are necro idle JSON, necro run JSON. So let's kill these first. So I want to go to this, make sure this isn't interfering with anything. So I just want to make sure that our assets are loaded in. If they're not being loaded in, we can attack it from there. So let's take a look at this. We've got our shared whole container called sprite, image data. So it's essentially this test. Should not go exception if bitmap image data is null. So everything's being loaded in, so that's a good sign. So let's the next step. Make sure our total directions is what we think it is. While that builds, let's pass this test. So this one's going to return null, and this should all be 0. Okay, so that, we got 8. That seems not correct. So I think we actually want to do this. Okay. Let's see if anything here. So we're going to set our current pose, get our image data from our current pose, set the direction. So we got our frames. Set the current direction, so we have the current pose frames. So this should work to here, ideally. And then here, while that's doing that, that should verify 0 times. And doing lots of things at once. Right, so that's more correct. So 15 is correct. it is setting the pose. Let's set the direction, see if this does anything strange. Really hope this is recording because I'm not getting the feedback from Twitch. It says live, but nothing's happening. Okay, so that crashed it. And we've got a bunch of interesting things going on here that we can check out. So let's go back to here. So set the pose, set the direction. So that seems to be a thing. Let's look here. So everything failed. Invoke 2 times. So it is definitely doing something with the set direction. So current pose frames. So I think it's the animation has not been created yet. So we need to do this. And I think we need to do this. That should clear that up. So, should not throw exception was there invoked 1 time. Get inspected 1. Let's see here. Should not throw exception if bitmap image data is null. So it was invoked. Image data was invoked. Once, and it should not have been. Oh, this actually should be invoked once. Let's go back to here. Okay. He seems to be plopping on stage. And so if we set the direction to 0, which we don't need because this will happen, let's start the animation. So this is our result. Unknown identifier image data. Actually, it should be. Ooh. No. See if that does the right thing. And figure out if this was a fluke. Okay, yeah, that passed. Alright, trace total directions. Reopen. Okay, so now he's animating. And now he's still skidding around, but still it works. Now what we need to do is we need to go to our this, make sure that this still works. Let's go back to our test. Should draw a bitmap. And that is invoked 2 times. And 128 bitmap x verify invoked 0 times because we don't have the bitmap data assigned. 128. So we drop our guy. Now he's changing his directions. We're getting really close now. Okay, so we need to go back to our game object. We're going to set our public function set pose. It's going to be our poses. And then we're going to talk to our display, set pose. If everything is hooked up, we should have no change on that one. We need to go to our playground and actually use those. So where's our playground at? Playground. And first thing we're going to do is going to say the last unit, set pose to poses dot idle. I'm sorry, not idle, run. And then we need to set the, when we actually get him in this position, we need to set him back to idle. Alright, let's build that. Let's run our tests. Perfect. Okay, now we need to do line 177. I think it's the same thing, cast any. So we need to pass this in. Something screwy there. Oops. Line there, and then 153. This here. Reopen. There's our guy, and he runs, stops, and changes his pose. Perfect. And all in perfect timing because now our test pass, our guy is running across the screen. Looks great. Let's do one little quick tweak, which I'm pretty sure is going to be not fully correct, but at least we can see what's going on better. And then we'll call this a day. I feel like we really made some pretty cool changes here. So there we go. That looks much better. And he runs around the screen and looks in the direction he wants to run. Perfect. We did it. Okay. So now, one last thing. I saw a trace statement that I want to get rid of. There we go. And that's it. So here we go. So get status. We have a bunch of new stuff. Get add assets. Get status. Get commit. Added our unit running and changing poses. Get push origin master. Get tag 2016 0329 let's say 1600 even. Get push origin that. Alright, there we have it. And hope you guys will have some fun with this. Start playing around, see what you think. Go ahead and subscribe to my YouTube channel for any sort of updates. I'm trying to do this every day, and more good stuff coming up. You guys have a great day.